We are Team 16460, the GEarheads. We are a third-year FTC team, and we have been a first team for 6 years. As a third-year team, we have taken a new approach to our team's organization, outreach, and our engineering method. We assign team leads for each part of FIRST. This includes roles such as the mechanical team leader, the software team leader, a qualifier leader, a documentation and awards director, and finally a communications director.
This season we made sure to focus on doing as much outreach as possible and connecting with the STEM community. We focused our outreach on enabling the growth of new teams by providing resources to startup teams such as coaching and mentoring FTC and FLL teams. We also developed and grew technical skills, sharing that learning with the FTC community through our YouTube channel, and provided teams that need computer resources by collecting, refurbishing, configuring, and delivering laptop computers to teams that need them. We were focused on starting new teams by mentoring 3 FLL teams. One example is FLL Team 45193, WC2G, who we have spent more than 6 meetings with them, teaching them how to effectively code and build their robot to accomplish their missions. These meetings we spend with them are important as it helps foster and develop the future of STEM and FIRST in the community.
We noticed that in our community, many startup FIRST teams don't even have access to computers for programming. We held computer drives to collect 79 used devices and $675 of donations. We worked with both our high schools and the Elmbrook and Brookfield public libraries to collect devices. With the devices we collected, we will either refurbish, sell, or responsibly recycle them. We worked with the Director of Technology in our school district, Dan Scott, to learn how to wipe the hard drives, get the proper Microsoft licenses installed, update configurations, and repair the computers. To date, we have completely refurbished 11 computers. We have worked with MSOE to find teams in need. We have donated 9 computers to 6 Milwaukee FLL teams through the Boys and Girls Club, the Dr. Howard Fuller Collegiate Academy, and to the Golda Meir School team. We expect to deliver a total of approximately 25 computers this year, with the rest being recycled or sold to fund needed supplies like cases and chargers.
Our project will also be displayed on CBS 58 on December 26th. To make this happen, we contacted Emily McTavish, a news producer at CBS.
Another video that we worked on were Skillshare videos. We have made videos about our fabrication process, wiring skills like soldering, and the process we call cardboard-aided manufacturing.
This flowchart helped us design our robot. First, we considered how points are scored and their value, helping us identify which mission elements are important and which ones are less important. Then we discussed design and teleop strategies. After we got all of this done, we talked about which requirements the robot might have to meet. We also had to take into account what subsystems we might need and what requirements these subsystems might need to meet. Once we finalized these decisions, we designed and developed our subsystems.
Our robot has 6 subsystems: intake, lift bucket, capstone arm, duct spinner, and odometry pods. The intake sucks in field elements, blocks, balls, and ducts by rotating 3 rows of O-ring material using a motor. The intake puts these field elements into the bucket, and then the lift takes these components to the desired level, and then the bucket rotates, letting the field elements fall to the desired location. The duct spinner spins the rubber duct game elements off the turntable in the endgame. The capstone arm grabs onto our capstone and allows us to put our 3D printed capstone onto our Alliance tower during the endgame as well. Finally, odometry pods allow our program to know the exact position and orientation of our robot at all times on the field. We made this decision to have precise odometry and to not drive over the field barriers.
To start software development early, we built a test jig robot early in the season. This robot allowed us to program our robot before having the final robot itself. The test robot had motors, actuators, and servos, but none of the mechanisms of the real robot. When the robot was constructed, we transitioned the software to the completed robot. This allowed us to get the teleop working on the real robot within 1 session in less than 4 hours. For autonomous, we programmed an OpenCV-based game element detection. This gave us a reliable way to detect the duct's position. We then transitioned to Roadrunner and Deadwheel odometry to control our trajectories. In teleop, we use a single-button state machine to simplify operations.
Thanks for taking the time to learn about the GEarheads. If you would like to know more about our software, check out our control award. Visit our website to see the robot and the team, or visit our YouTube channel to see where we posted the first 3 Skillshare videos.